The definition of x-intercept means the y value, the function value is 0.
Yeah. So it's negative 1/6.
So we set this function to be 0. So here, we take this function. Oops. We take this function, we set to be 0, right? Because y value is 0. That means f of x is 0. Then we solve for x. So let's do that. So we need to find this x value. You see the x is empty here?
Yes.
We need to find the x value. So negative, the function is negative 3x squared minus x plus 2. We set equal to 0. Because the y value is 0. So we set this one function to be 0. Now let's try to factor it. So we see the x squared term is negative 3. It's negative. Let's change to be positive. How do we change this to be positive? We just multiply negative 1 on both sides. Because 0 times negative 1 will still be 0. So we just have to flip those signs on this side. So negative 3x squared becomes 3x squared, positive 3x squared. Negative x becomes positive x. Positive 2 becomes negative 2 because we multiply every one by negative 1. Now we have the leading term, x squared term, have a positive number before it. Now maybe we can try factor this. So we can try to factor 3x minus 1 times x plus 2. So 3x minus 2, x plus 1. Let's see if this works. So my first try. So I'll try to factor this way. So if I factor this way, oh yes. Do you see this works?
Yes.
You see the middle term I get from this smiling face. Negative 2 times x give me negative x. 3x times 1 give me positive 3x. 3x minus 2x give me positive middle term x. Okay, so this works. So by using 0 property, I can split into 2. So I have 3x minus 2 equals to 0, and x plus 1 equals to 0. Right? This is by 0 property. If I have something multiply something else to be 0, that means either one or both of them to be 0. I solve this. I get 2 solutions. So x equals to 2. So first I add 2 on both sides. I get 3x equals to 2. Then I divide it by 3. So I get x equals to 2 over 3. And for the second equation, I minus 1 on both sides. I get x equals to minus 1. So I have 2 x values. Right? Make sense?
Yeah.
So that means we have 2 x-intercepts. So x-intercepts we have 2. We have negative 1 comma 0 and 2 over 3 comma 0. X-intercept we have those 2. So now we have all those information ready. We have these 3 things we can graph. We have vertex, we have x-intercepts, we have a y-intercept, we can graph. So y-intercept is 0, 2, 0, 2. Let's graph. And we know this kind of quadratic function. Quadratic function is either upward parabola or downward parabola, right? So I have 0, let's see, this is 0, 2. So this is a 2, value 2. Let's say this is negative 1. This is positive 1. Well, let's mark some points, right? So let's see. So our vertex is a negative 1 over 6. So negative 1 over 6, let me use blue color. I divide this into 6 parts, right? So -1/6 is probably somewhere here. Then y value is 25/12. That's a little bit more than 2, right? We see that? Because 24 divided by 12, that's 2.
Right.
So 2 and 1/12. So a little bit more than 2. So that means my point is here. So 1/6, -1/6 for x value. So this is my vertex. So this point is my vertex. And this point is my y-intercept. Then I have 2 x-intercept. I have -1, 0. So which is this point. -1, 0. And a 2/3, 0. 2/3 somewhere here, right? A split from 0 to 1 split into 3 parts. So 2/3 is somewhere here. So my graph looks like this. It's downward parabola. It goes through this y-intercept. It goes through this x-intercept. And this is not that sharp. This is round, the vertex is roundish. Something like this. Okay, I believe this is same as yours, Jeremy, right?
Yes, it's the same.
It's the same, right? Okay, great. So I guess everybody's okay with this question, right? With graphing quadratic functions. Anybody has any question?
No, I'm good.
All right, great. Thank you, Jeremy.
No problem. Sure. Thank you.
Okay. Lola has a question. Lola, go ahead.
Professor, it's not about the question you just finished. I want to ask you a question about the finals.
Oh, okay.
Go ahead.
Yeah, what about the finals?
Okay, so first, my first concern is like I read about the notes you left on Blackboard and via email about what and how we should submit the finals, right? And then I read something like you told us to like attach our email, our ID to like the top of the page before submitting. Why can't we just have our ID number there? Because it's like kind of weird to like take a picture of my ID for an exam. Like, I don't know.
Well, just want to make sure, you are the person, the
Then we can
student.
just put our ID number. That's what
I'm
professors
sorry?
ask for the most.
I'm so sorry. What was it?
I said we can just put our ID number. That's what professors ask for the most. Our school ID number can just do that.
Oh, you mean write down the ID number instead of put the pictures on top of it?
Yeah.
Oh, you know why, Lola? Because this finance is not going to be practiced. It's going to be, whenever you do on your own. So by putting the picture ID on that, it's just to show, it is a student who finished the work.
Well, another person can finish my work for me and I'll still give the person my ID and take a picture of it. That I don't think that works like that. I don't know. It's a little bit weird.
I see. You know what? In Hunter we do this. I mean, this is
No,
Gambia. Yeah.
I actually have been to Hunters
You
for
don't like
2
it?
semesters before, and they only ask us for ID number, really, for the most part.
Okay, so you don't want to put
I
your
don't want
picture.
to take a picture of my ID and attach to an exam. No, it doesn't. It's a little bit weird. Like, I don't know.
Okay, then I don't know. Right, Rena is saying, let's see. Right, if you guys think it's weird. Okay, Jeremy agrees. Rena is saying, I mean, she's right. Other professor in Ghana never ask for a picture, just the ID number. I see. Because when you go to Hunter College, you're going to be asked to present your ID. Anyway, okay. I mean, right. If government, like, if you don't want to show your picture ID, write your ID number on top of it. That's
Yeah.
okay with me.
Okay. So I have another question.
Yes, go ahead.
So is the review for the final, is it the same outline as the final? Like, is that what our final gonna look like?
Yeah, you're
Why can't
right.
we have it the same way we had our own works? That's like I was looking at the review work and there like some word problems and stuff. Like I hate word problems. We never did word problems for homework. So like why do we have to do it for finals? I don't understand.
Oh, really?
I'm so stressed for this class.
Okay, hold on. I choose different numbers, you mean?
Like why can't you just like try to like outline what our finals would look like, so that we know what chapter this is in. And you don't even have to tell us like what chapter this is in, but like for example number 8, look out like that question look like, it looks like, I don't know, it looks like something I might be able to do, but at the same time like isn't it like more easier for you and for
Mm.
us to like have the same like not the same question but like questions that look like a lot like our homeworks would look like, because our homeworks don't look like that.
Oh, I see your point. I see your point. Okay. Um, all right, we can talk about that. You know, if those ones are not similar to your homework, it feels strange, I can cut out from the review sheet.
Okay.
How about that? Okay, tell me which ones feel strange.
I don't know what I'm looking at, but it's just like I don't understand what's going on in this review sheet, but okay. Yeah.
Yeah, you can tell me which ones look strange to you. Because
Number
I
8,
thought,
I
huh?
don't know what question is that about. And then like you see the way we have like word problems in there, we usually don't have
Number
word
8, right?
problems.
So number
Like
8.
number 8 was like the first question I saw, and I was like, wait, what's going on? And then like there are like other word problems in it. Like for homeworks, we don't usually have word problems. So like I don't get why we gotta have word problems for finals. I mean, if we're gonna have word problems for finals, we should have practiced that doing homework and stuff, so that we like are more like familiar with it on
Okay,
different
okay,
topics.
I
But
can
we
take
don't
out
we
number
don't
8.
practice that.
Okay, we can take out number 8. Let's take out number 8. Yeah, okay, let's take out number 8. What else?
Another word problems.
Let's see. Maybe 7, number 7?
Exactly.
I thought we did all those kind of problems. Maybe I remember
No,
wrong.
no, I can't remember doing that in homeworks.
Okay, number 11?
Yeah, basically we don't have like word problems in homework. That's just my point. Like,
I
so
see, I see.
we
Okay,
should
I'll
have
take them out. I'll take them
we should
out.
just have questions that we've practiced about, so we are more familiar with it. But if you have word problems, I never solve them during homework. So how do I like fix them or do them for finals?
Um, okay, so those are the 3 word problems, right? 4. So let's take out number 8. Let's take out number 8. Let's take out, what's this number? Number 7. Let's take out number 11. Let me write down the numbers.
So basically, we can just have like open response questions, or like like questions that are like just like key concept questions. Like if we are talking about maybe composition of a function, we know that like the question is like about composition of the function, and like it's like exactly what the concept is about, just like what the homework looked like.
Yeah, that's what I was trying to do.
Well, but all this word problems, they freak me out opening it and seeing word problems.
I see. I see. So this is a 9. And 13.
Look at that. We never made this type of tables doing what's the table about? What's the table supposed to be about? Look at
Which
that.
one?
This table you the one before 13, that's 12. Yeah. The table, what is it about?
13?
I was so confused looking at this review sheet.
This one is
So,
hard.
yeah.
I
It's
think
hard.
I think Lola, everything we covered in this class, but maybe
Wow.
I did not assign you the word problem. So you were talking about 13 or this table here?
Yeah. Yeah.
Table you know very well. Okay,
No,
let's
I don't
see.
do that no more.
So the angles, right? The angles in radian. Angles can be in degrees or can be in radian, right? There's a correspondence between degrees and radians. If it's 0 degree, that would be 0 radian, right? If it's 30 degree, remember how do we convert? We have 180 degree equals to 1 pi. We use this, pi means pi radian. The pi we use for circles. And but you have done, right? So this table will help you when you go to calculus class. Okay, the purpose of this course is to prepare you for calculus course. So those are some important angles. You need to know about the sine values, cosine values. Once you know those values, you will know tangent values. The purpose of the table is this. All right. Any other questions? Okay, anybody else has any questions regarding this homework, this review? Elizabeth, yeah, go ahead.
I just wanted to ask about, because I heard that Lola mentioned about how we have to basically submit the final, but I don't
Yeah.
see it like anywhere, the instructions. I just see that like the date that you sent through email, like when is it gonna be posted and when is it gonna be due. And about that, I also wanted to ask, um, do we have the the chance to open the final and then leave it open and work on it while it's basically done, or do we have to, once we started, just finish it right there?
This is something new to me too.
Okay.
Let me share my screen with you. Let me just go to content. Okay. You see here on the right side, on the left hand side, the blue area,
Mm-hmm.
the very bottom one says the final exam submission.
For some reason, I cannot see that in
Oh,
my
no,
page.
you don't see it yet. You will see it on
Oh,
December.
okay. Got
Yeah,
it.
it will be open on December 16th.
Okay, makes sense.
In there, right, let me open it for you. In there, when you open it, when it opens, you will see a final exam, a PDF file.
Mm-hmm.
All right, and it has instructions to tell you how to submit your final. So it will open on December 16, 5:30 a.m. and it will be closed on December 19, 11:59 p.m. So you have 3 days to work on this, work on the final.
Right, but do we have the chance to, once we started, basically? Okay, so that's a PDF, so that I could basically just open it. It doesn't have to be like, okay, it's not the same as other finals. That's what I'm trying to say, because that's a PDF, right? So I can just open it and work on it. It's gonna be like answering the questions on my notebook, and
Yes,
then
yes.
okay, and then
Yeah,
I would just take and send it through. Okay,
yeah,
I think I get it.
through the submission button. You click on it somewhere that will allow you to submit. Okay.
Okay. So yeah, because I'm trying to understand it because like usually exams are like you open it and they are like right there live. You are given like a certain amount of limit time or not sometimes. But I see that this is like a PDF, so I would just see the answer and then basically answer it on my notebook and then send the pictures.
That's right. It's not
Okay.
online. It's not online.
Okay. Makes
Yeah.
sense. So we have the 3 days. I got that. Thanks, Professor.
You're welcome.
I have a question really quick.
Yeah.
For the final, so let's say if we show our work and we just somehow don't get the right answer, do we still get credit?
Of course.
Okay.
Of course. That's why it's very important to show steps.
Okay.
Even if you get the right answer, but somewhere you have something right, and you will get credits for the right things.
Okay. Thank you.
You're welcome.
Can you please go over one of the problems in the review sheet?
Sure.
There's no number, but it's like under the number 8 that you crossed out, it says find the shift of the following functions.
It's in the first part, which number?
It's right there, like find the shifts of the following functions.
Okay. So find the shift of the following functions. Or right. Okay, I see. Yeah. Let me write here.
I didn't really understand like what shift and like are those two like functions together to find the shift together with them, or like it made no sense.
Yeah, you're right. This makes no sense. I don't know. It's being cut out because when I copy paste, something being cut out. So understand like this. Understand like write g of x in terms of f of x. It's better to say this way. So we were talking about transformation functions, right? So let's use this as example. Let's use sine x, cosine x as one of the examples, because sine x and cosine x are the most difficult ones. So let's see if we have f of x that way, g of x may be -3 sine x. So we're treating one as a basic function. We're treating, let me change my color. We're treating this one as a basic function or reference function. What does that mean? That means, then we're treating g of x as a transformation of f of x. So that means, I have the graph of sine x in my head. Why it does not stay? So we graph our sine, we have our sine of x in our head. Then we think about the g of x. So g of x is a transformation of f. How is g gets transformed from f? First we see negative, then we see 3. -3, so shows us the amplitude. So sine x, the highest point is 1, the lowest point is -1. But here, because we have this 3, the highest point will be 3, the lowest point will be -3. And then this is a negative. What does negative mean? Negative means the positive value being negated to a negative value. Let me just draw in another color. So the positive value now being negated, right, becomes a negative value. So this part of the graph becomes like this. And the other side, the negative value now becomes positive. So this will be my negative 3 sine x. So this is talking about the transformation of it. And then if I want to write g of x in terms of f of x, how do I write? I can write g of x equals to negative 3 f of x. Let's make sense of this. So I have two functions. I have f of x, I have g of x. I'm saying g, f, and g are closely related. How are they related? I can write g in terms of f. Right? Transformation, that's transformation. Picture-wise, we call transformation. But algebraic-wise, we can write one function in terms of another function. Okay, now let's go back to A and B. So let's say G. So let's say A. So A, f of x equals negative 3x minus 7. And g of x equals negative 3x plus 12. Let's see how we can write this function into a g in terms of f. So let's just try to find f in g. So that's negative 3x we have already, and we need a negative 7. But we have 12 in g. So if we make negative 7, that means we have to plus 7, right? Then plus 12. Plus 7 plus 12, that's plus 19. Let's see if this makes sense. So g of x, we can write as negative 3x minus 7 plus 19. Because negative 7 plus 19 is 12, right? So now we see f here. We see function f. Negative 3x minus 7, that's f, right? So that means we can write this function, we can write g in terms of f in this way. So equals to f of x plus 19. Let's see if this makes sense. So g is negative 3x plus 12. So we're rewriting 12 into 19 minus 7. 19 minus 7. Why we do that? Because negative 3x minus 7 is f of x. Same thing, if we want to write f in terms of g, we could do that for this question as well. Okay, any questions for this?
No.
No? Okay. So transformation, do we see this is a vertical shift?
Yeah.
Vertical shift, right? So basically g is pushing f 19 units up. So that's what this shift is talking about. Finding shifts of the following functions. You can think this way, or we can think this way. So talking about shift of functions is picture-wise, to see from the graph. Talk about writing one function in terms of the second function, that's algebraic-wise. It doesn't make sense?
Yeah, it makes sense. It just, these problems are like, it's not really something we did. Like, you didn't ask us in the homework to find a shift from writing the g of x in terms of f of x. So this is like the first time that you showed this how to do.
Oh, I thought we covered the transformation of functions. We did not?
We did transformation of functions, but you never asked us in the homework how to find a shift.
Oh, really? Okay, remember last time. Okay, let's see this one. I remember someone presented this one. F of x equals to 3 plus sine x, right? I remember one time someone showed this one. So how to graph this one? This one basically to, we have sine function, and this function is just a vertical shift, pushing up the sine 3 units up. And also we talk about horizontal shift. Right? This is a vertical shift. Horizontal
No,
shift.
that's not what I meant. I know we did that, but like for this problem, specifically for these numbers, like f of
Oh,
g of x, we didn't do this in terms of finding the shift from two different functions together.
okay. All right. So basically this is a vertical shift. This is a vertical shift. And the second one is a horizontal shift. We see this, if we use a sine function as example, it could be f of x equals to sine of x minus pi, right? You see here, x value is being changed. X value, this is a horizontal shift because x value is being pushed pi degree to the right. Horizontal shift. So we see this one, you see here we have 2x squared minus 2x plus 1. Then now we still have 2 something squared minus 2 of something plus 1. But we see x value is being shifted to the right 2 units. So this one algebraically we'll say g can be written as f of x minus 2. This is one way to see it. So to see the shifting in algebraic expression, we can write this way. That means write one function in terms of other. But if you get confused with this one, forget about it. All right. You can also figure out, find the shifts. Shifts means we have two kinds of shifts. We have vertical shift, going up or going down. We have horizontal shift, going to the right or going to the left. So two kinds of shifts, vertical shifts, horizontal shifts, and then we have each one, we have two directions, up or down for vertical shift, and left and right for horizontal shift. Right? So this one, so the first one is vertical shift. Vertical shift up 19 units. The second one is horizontal shift, shift to the right 2 units. If this were plus 2, that means shift to the left 2 units. Make sense?
Okay, it makes sense. I guess need to practice more because we never really practiced this type of problem.
Okay. All right.
I have another question from the review.
Yeah.
Number 3, I don't understand the sentence. What do you mean by identify the following function and write them in the standard form? They're already written.
Oh, if you could, let's see.
No, not that one. It's number 3.
Or number 3.
Not that. It's another. I think other page. Maybe page 2.
Or you mean in part 3?
Oh yeah, there. No, I think up. It says a number 3 on it. Not this one. No. I think it was up a little higher up. Right there, like identify the following functions and write them in the standard form. Like I don't understand the sentence.
Oh, okay. Let's see how many kinds of functions. This is a good review. How many kinds of functions do we have learned in this course? Let's count our functions. Let's count the type of function we have learned. So, Rina, can you give me a couple of functions? Just give the names.
I don't understand. What do you mean to give you functions?
Oh, okay.
Oh,
Let me
linear function.
make some list.
Oh, yeah, there are linear function, quadratic functions, and exponential.
Right, when we say identify, it means to give them names. So
Okay.
functions, regular functions. Let's keep listing some of them. Also, let's think about the standard form. So what is the standard form for linear functions?
Y equals mx plus b.
Right. So, well, we could use f of x or y equals to mx plus b. For quadratic functions,
I think it was something like, I don't remember, like b times number and then to the x power. Yeah,
ax
something like that.
plus bx plus c.
Oh, okay.
The second kind. Let's make the list. This is good review. So first kind of question is linear functions, very easy. Why is called linear? Because the exponent on x is 1 by default. Quadratic function means x, we see x squared term. So the next one, polynomial functions, right? Well, let's see here, but let's just do this one. 1, 2, 3. We have learned exponential functions. Exponential function. I'm not going to read the functions, okay? I'm going to only read the name. So exponential functions. Do we remember the standard form? F of x equals to some number, maybe we call a, multiplied by another number raised by x. Right? Exponential function. Then we have logarithm function. So let's see, 4, we have logarithmic function. What's the standard form? Standard form is f of x equals to log base a, then some x, right? Of x. This x could be big fat x. Then trig functions, right? Trig functions is basically sine, cosine. All right, let's check. So let's see the first one. So what do we think about the first function? We have a number 5 minus half x.
So that's linear.
That's a linear function. So read in a standard form, how do we write it?
Negative 1 over 2x plus 5.
That's it. That's it. And what about second function? What kind of function is the second function?
Quadratic.
Quadratic. So we just write it in terms of ax squared plus bx plus c. Write x squared term first, negative 3x squared plus half x plus 2. 3 is kind of troublesome. What kind of function is 3?
Is that exponential or logarithmic?
Exponential. Right, it's exponential. Logarithm, we see log, ln. We see log, ln here. So this is exponential. Why is exponential? Because we see x in the exponent, right? So how do we figure out this one?
Do we multiply by 5 to get rid of the 5?
Can we multiply by 5? If we multiply by 5, we would get 5 f of x equals to 3 raised by 2 minus x, right? But we want to keep f of x. We don't want to do 5 of x. Well, let's just split. So we have 3. Let's understand. So let's put a 1 over 5 up front instead of multiply by 5. So I have a 3 raised by 2 minus x. So that means we have a 3 raised by 2 times 3 raised by negative x. So one step closer to the standard form. Now let's see next one. So 1 over 5. So let's keep simplifying, right? What is the 3 squared? 9, right? Then 3 raised by negative x. When it says use parentheses.
That's negative x times 3.
No, 3
Oh.
raised by x, that means 1 over 3x.
Oh, yeah.
So now let's keep simplifying because we need to find A, we need to find B. So 9 over 5, that's A, times 1 over 3 raised by x. Right, so now we say A equals 9 over 5, B equals 1 over 3. We did have a homework like this.
I don't remember doing
I see.
identifying the exponents.
Probably didn't have. Okay, but you know, remember those what do you call it? Standard forms. So exponential function has standard form like this: a some number multiplied by base raised by x. That's the standard form. Then
Are you saying that what you did there, the 9 over 5 times 1 over 3, that's the answer?
Yeah, that's the standard form, right? You see, in this case, you see this is a 9 over 5 is a number. Then the base is 1 over 3. And then if we graph this, it's clearly exponential decay goes this way. Because 1 over 3 is less than 1. Make sense?
Yeah, the graphing makes sense. Okay, so since we didn't really do the, I mean, it's okay. So then for 4, do we have to do the same thing?
For 4, and they identify the exponential functions for growth or decay and then write them in standard form. Exactly. Exactly. So the first one is 9 times 3 raised by x, right? So a would be 9, the base would be 3, and you know this is a growth because the graph goes this way.
Wait, where did you get 9 from?
Because I see 3 raised by 2.
Okay.
Right, this is for exponential functions. Exponential functions, so this one we can write as 3 raised by x times 3 raised by 2. Then 3 raised by x we cannot simplify. But 3 raised by 2 we know. 3 raised by 2 is 9. That's 9 times 3 raised by x. In this case, we say 9 is a number, 3 is a base. Because 3 is bigger than 1, so that's exponential growth. The second one, you can do the same thing. You'll see the number is 4, the base is half raised by x, half is less than 1, so the graph is exponential decay. Okay. Yeah, I mean, this course is hard. It's, you know, it's even harder than calculus itself. But without the foundation of this pre-calculus, it will make calculus even harder.
It's not really that. I'm sorry for cutting you off. I was just saying that it's not really that. It just like the review sheet that you gave us, these are not really the problems that were on the homework that you assigned.
Yeah, it's not directly similar to the homework, but the ideas are the same. Understand your point.
Can I ask you one more question from the review?
Of course, keep asking.
All right, so for number 9, how do I write that equation in exponents?
The same one here, right?
Oh yeah, it's like right there, number 9.
Okay, number 9, rewrite the equation ln 10 equals to, maybe this space is confusing, ln 10.
Because I don't understand, like I know how to write it in log, but I don't know how to write it in exponents.
Oh, okay. So ln 10 equals to 2.303. What's the base of this log?
10.
No, the base of this log is e. This is a natural
Oh,
log.
okay, yes.
And the e raised by 2.303 equals to 10. Remember log and exponential, we can switch the order, write one in terms of another.
But the question is asking not to write this in like using exponents instead of logs.
Exactly. So now do you see I have e raised by 2.3 over 3. 2.3 over 3 is the exponent.
Okay, so that would be the answer.
Right.
Okay.
Okay. Okay, good. Any other questions?
For 12, is that exponential function?
Exponential function is a 12 right here.
How do you solve 12? Is that exponential?
Solve exponential equation. Right. How do we solve this? We have e to, so this is nothing here. That means multiplication, right? So when we multiply two things, when the base are exactly the same, we can combine the exponent. So we write 2x minus 1 plus raised by 2x minus 1 plus 3x plus 4 equals to 3. So we just combine those two terms. We have e raised by something times e raised by something else. We just write in one term as e raised by adding the two exponents. So when we add, so we get e raised by, so 2x plus 3x, we get a 5x. And the negative 1 plus 4, we get a plus 3 equals to 3. So how do we solve for exponential equations? We need to take a logarithm on both sides. Right? So we take logs on both sides. We have ln of the e term. So ln e raised by 5x plus 3 equals to ln 3. So basically we're just putting ln on both sides. We're taking logarithmic on both sides. So now, because this becomes exponent, right? Because this in the log 5x plus 3 is exponent of e. So we can move this 5x plus 3 up front of ln. That equals to ln 3. We move this 5x plus 3 in front of ln. Then now, what's ln e?
1.
1. So that means we're left with 5x plus 3 equals to ln 3. Right? ln 3 is just a number. We don't have to use a calculator to approximate. Just keep as ln 3. It's a number. It's exact. So how do we solve this equation?
Divide by 3 on both sides.
with minus 3 on both sides, right?
Oh, -3.
Right. With minus 3 on both sides, we'll have 5x equals ln 3 minus 3. Then we divide by 5. So we get x equals to ln 3 minus 3 divided by 5. Whatever the number is, we just keep it like that. We don't have to use a calculator to approximate, because this is exact value. You know, when you go to calculus course, we don't simplify these kind of numbers. They are irrational numbers. We just keep them as it is. We don't want to punch into a calculator to get approximation. We want to keep it exact like this. Okay, does this question make sense?
Yeah, it makes sense. So then, can you do one of the problems for like 10 or 11? Because like I know how to convert radians and degrees, but I don't know how to find the same value that has like a given value of cosine.
Is this 10?
No, not that one. I think it's below.
This one? 10, 11?
Because like I know how to convert the degree and radians, but like I don't know if we did something that had to find the same value that it's given you cosine 60.
Okay, before we do this, I think it's a good time to do this table. Oops. Let's do this table first. This table is so important for you getting into calculus class. All right, let's see 0. We use this equation to convert from radian to degree, from degree to radian. We use this equation. Okay, this equation says 180 degree equals to 1 pi radian. All right, make sure we equal those. So 180 degree equals to pi radian. So what's so 0 degree is 0, of course, 0 degree is 0 radian, right? So I have 0 here. So that's 0 radian. Radian is RADIAN. Usually we use rad, RAD. What about 30? 30 degree. Let's use this equation. So I have 30 degree now. How do I find its so 30, we can think this. 30 divided by 180. 30 and 180. 30, well, think about this. 30 times 6 is 180, right?
Mm-hmm.
So that means that equals pi over 6. Right? Basically, we divided by 6. So we divided by 6 on both sides. We divide 6. So here we get 30. We divide by 6. On this side, we get pi over 6. Do you see that from this equation?
Yeah.
Okay, so 30 degree equals to pi over 6. But let's see 45. If we do 180 divided by 45, what do we get? We get 4, right? So that means 45 is pi divided by 4. What about 60? If we do 180 divided by 60, what do we get? We get 3. Pi over 3. All from this equation. All from this equation. What about 90? 180 divided by 90? That's 2. So equals to pi over 2. Well, 180 equals to pi. Right? So 180 equals to pi. Pi, we write this way, pi. Let me see. pi, can I write here? Pi, you know the pi, right?
Yeah.
All right, pi, because I cannot write pi here, so I use pi to represent the pi. 270, right? You could use 270 divided by 180, or 180 divided by 270. In any case, oops. You get 270 equals 3 pi over 2, or 3 over 2 pi. Either way, how you write it, okay, 3 pi over 2, that's fine. What about 360? 2 pi, right? Because 360 divided by 180 is 2. 2 pi. So 0 degree equals 0 radian. 30 degree equals pi over 6 radian. 45 degree equals pi over 4 radian. 60 degree equals pi over 3 radian. 90 degree equals pi over 2 radian. 180 degree equals pi radian. 270 degree equals 3 over 2 pi, or 3 pi over 2 radian. 360 degree equals 2 pi. Okay, now let's think about the sine values, cosine values are also important to remember. Sine 0 is 0. Cosine 0 is 1. And then opposite, if we do sine, okay, later on. So sine 0 is 0, cosine 0 is 1. Or sine 30 has a beautiful value, half. Cosine 30, square root of 3 over 2. A tangent we know is a sine over cosine, right? So 0 divided by 1, we know this is 0. What about sine 45? Sine 45 is square root 2 over 2. Cosine 45 equals the same thing. So those two values are the same. And the sine 60 is the square root of 3 over 2. Remember we talked about cofunctions? We have this relationship. That relationship is saying sine of x equals to cosine of 90 degree, or pi over 2 minus x. Okay. Okay, pi over 2 minus x plus x equals pi over 2. So when two angles adds up to be pi over 2 or 90 degree, they are complementary angles. So 0 and 90 are complementary angles. And 30 and 60 are complementary angles. 45 complementary angles with itself. That's why sine value and cosine value are the same. Because sine 45 equals to cosine 90 minus 45, still 45. So sine 45 equals to cosine 45. So that's why we have this square root 2 over 2, square root 2 over 2, both for sine 45 and cosine 45. And then by the cofunction, we know sine 60 here equals to square root 3 over 2. And cosine 60 here equals to half, because they're cofunctions. Well, 90 and 0 are complementary angles. So sine 90 equals to 1 equals to the cosine value of 0. Right? So if I draw different color, let me use a different color. Let me use green color. So here, oops, still wrong. So this value is the same as this one, right? Because sine of 90 equals to cosine 0, and those two, and cosine 90 equals to sine 0 by this cofunction, okay, by this cofunction equation. Then sine 180 equals to 0. That's sine pi. Sine pi equals 0. Cosine pi equals to -1. Then sine 270 or sine 3 pi over 2 is -1. And cosine 270 or cosine 3 pi over 2 is 0. Then 360 is the same as 0 because remember we run the circle. We start from 0 when we run a circle. Basically, we run 360 degree or we run 2 pi. You know, we came back to 0. So sine 360 degree equals to sine 0, which is 0. And cosine 360 degree is the same as cosine 0 or cosine 2 pi, which is 1. All right, the tangent value you can derive from this sine and cosine value. I think we did talk of this table in class, right? But if we don't have time to watch the class recordings, probably we feel strange about this table.
Yeah, so now that the table is done, can you please show us how to do at least 10 or 11?
Yeah, let's do 10 and 11.
It's on the top of the table.
Right. So let's do 10 first. So 10 is saying find the angle between 0 and 360. That means in the 4 quadrants, right? Why it does not stop? Okay, we have these 4 quadrants, right? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So 0 to 0 starting from this point. Let me use a different color. You know, we always measure our angle. We're starting from the positive side of x-axis. We're starting from here, right? From 0 up to, so we run one round. When we run one round, we come back to 0, which means we made 360 degree, or we made 2 pi. So seeing which, okay, we need to find the angle in these 4 quadrants, which has the same value as cosine 60. Okay, let's now think about a cosine 60 degree. I'm going to use D to represent, all right? Cosine 60 degree. What is a cosine 60 degree? By the table, we know that equals to half, right? Positive value. So remember, all students, all students take third quadrant, take fourth quadrant, calculus. Also, first quadrant, every trig function is positive. Second quadrant, only sine and its inverse cosecant being positive. The third quadrant, only tangent and cotangent being positive. Fourth quadrant, only cosine and its inverse secant being positive. So cosine 60 in the first quadrant is positive. Let's see 60 is somewhere here, right? This is our coterminal line. So our angle, we're talking about this angle. This is our angle measure, 60 degree, or pi over 3. Right? So which other angle give us the same value? So cosine is still, so this equals to cosine some other angle. What do you think? Has to be in the fourth quadrant, right? It has to be in the fourth quadrant. And its reference angle has to be 60. Remember, talk about the reference angle? Because we're looking at different triangles. In the first quadrant, we're looking at this triangle. So let me make this a little bit longer. We're looking at this triangle, first quadrant. And second quadrant, we drop a perpendicular line to x-axis. We're looking at this triangle. So the reference angle is 60. But what is its real angle? Because we always measure from positive side of x-axis. The real angle is from 0 up to this coterminal line. Does that make sense?
No, like I don't understand which angle is this. Is that cosine 60 the answer?
Cosine 60, this is a reference angle, right? Cosine 60 equals to half. Cosine 60, but we want to find another angle, which is the cosine of the angle also equals to half. So do you see cosine 300 degree? Also equals to half. Oh, I see. Okay, hold on a second. You're right. Okay, I did not assign you this kind of homework. I assigned you something else. This one, right? 14, 15. So 14, 15. But anyway. So this is when we talk about reference angles. Let's go back a little bit. Let's go back a little bit. Okay. So first quadrant, so we're talking about these all 6 trig functions, right? Let's write here. So we're talking about sine. Let's use x for the variable. Cosine variable. Tangent variable. Then sine, inverse of sine is cosecant x. The inverse of cosine is secant x. Inverse of tangent is cotangent x. Of these six trig functions, right? So if the angle between 0 is between 0 and 90, which is in the first quadrant, the angle between here in the first quadrant, all the 6 trig functions are positive. Sine 60, cosine 60, tangent 60, all positive. Right, so cosine value is positive in the first quadrant. And also cosine value is positive in the fourth quadrant. Here, in the fourth quadrant. So what is the angle there? So we need to find the angle, cosine of the angle equals to cosine 60. Look at this triangle. So each quadrant will form a triangle. So our angle, well, reference angle is this guy. That's our reference angle, right? And this reference angle we know is 60. But that's a reference angle inside this triangle. What's the real angle? The real angle we always measure counterclockwise. We start with this positive side of x-axis. So we measure the angle. So we're starting from here. We need to run to this. Start from here. We need to end up at this coterminal line. Right? So this is a true angle measure. So what is this true angle measure? Do we see that's 360 degree minus 60?
Yeah.
Okay, so that means, well, 360 minus 60, that's 300, right? So the answer for this one, for 10, is a 300 degree, or you could use radian to answer also. Then you have to convert. Does it make sense? So basically, this is finding reference angles. Well, let's see the 11. 11 is saying find an angle between 0 and 360, which has the same value as sine 0. Well, sine 0 is 0. What's another one? This one we don't have a picture. I'm sorry?
Cosine 0.
No, we want to find the angle. We don't want to find the trig functions. We want to find the angle. So basically, this is given reference angle. We want to find another angle. You see 180 degree, right? We can also check from this table. Oh no, table, where is the table? Table here. Sine 0 is 0. You see 180.
Okay.
Sine 180 is also 0. Okay, so this question may look like a very complicated. No, it's not. It's okay. Looks like complicated. All right. Any other questions?
Since it's review, can you please go over maybe 14 or 15?
14 and 15. You mean those two?
Yeah, just for review.
Okay. So let's see 14 and 15. So 14 is saying given tangent t equals to -7 over -3 over 7. Well, let's draw our quadrant again. Because when we deal with trig functions, we deal with 4 quadrants. Oops. Okay, remember all students take calculus. Tangent to be negative, that means we need to draw triangles in the second quadrant and in the fourth quadrant. Let's draw triangles in the second quadrant because tangent being negative because we have -7 over 3. Let's draw one in the second quadrant first. So I have this triangle, right? So T is here. So this angle is T. Oops. This is the angle we're talking about. This is the angle T. T. Okay, so this is the angle T measure. But this is reference angle, right? What's the real angle? The real angle we see is from here. When we really measure, we measure from here to here, right? That would be pi minus T. That's a true angle if it falls in the second quadrant, right? But anyway, okay. So tangent T equals -3 over 7. So we know tangent T equals the opposite over adjacent, right? opposite is above x-axis. That's positive. So we know this is a positive 3. And adjacent is a negative, right? Because it's on the left-hand side of y. So the negative x value. So here negative 7. Negative 7. So positive 3. Maybe I read here. Okay, does this make sense? That means
Yeah.
my y value for this triangle, for this one, is 3. My x value for this point, so remember this called terminal point? Terminal point.
Yeah.
So terminal point, I have x value being negative 7, y value being 3. That's my terminal point. Why doesn't move? Okay. Doesn't move. Let me delete them. Okay. Our terminal point is negative 7, comma 3. So which y value is positive? Positive 3. X value is negative 7. Because we're looking at the triangle here. All right, now, so t, right, t is in between of half pi and the pi. Okay, I did it right. Because if they give me the second condition is in the third quadrant, I would draw a triangle in the third quadrant. But because this second condition, so I would form a triangle in the second quadrant. The tangent value being negative, and also the angle is in between of half pi and the pi.
So it cannot be in the fourth quadrant.
It cannot be in the fourth quadrant, right?
Okay.
Because t is restricted with this. All right, now what do we have to do? We need to find the cosine t and sine t. We can go by the definition. So how is sine t defined? It's opposite over hypotenuse. Oh, we don't have hypotenuse, right? So we don't have hypotenuse. So we need to solve for hypotenuse. How do we find this hypotenuse? By Pythagorean theorem, right? So hypotenuse would be square root. Let me not write square root first. That's square 3, which is 9. That's square 7, or negative 7, 49. So we get 58, right? Because this side, the length of this side is 3. The length of this side is 7. So do 7 square plus 3 square, which is 9 plus 49, which is 58. That's square root. So the number for the hypotenuse is a square root of 58. Pythagorean theorem, right? Okay, now I have my hypotenuse. So sine t is defined as opposite, which is 3, divided by square root of 58. So if I want to rationalize, I would write 3 over 58 square root of 58. Let's see if this makes sense. Does this make sense? I draw the triangle in the proper quadrant. I find its hypotenuse, because hypotenuse is not given, but the definition of tangent have opposite over adjacent. So in the second quadrant, I figure out the opposite side, the y value is positive. The x value is the adjacent side, it's negative 7. So then I find out the hypotenuse is square root of 58. So how do I find sine t? I use the definition opposite over hypotenuse. Opposite is 3. Hypotenuse is square root of 58. That's sine. Or now let's find cosine. So cosine t equals to, we use the definition again, equals adjacent side, which is -7, divided by square root of 58. Well, if we rationalize this, because usually we don't want the denominator to be an irrational number, then -7 over 58 square root of 58. Okay, let's make sure this makes sense. If it doesn't make sense, let me know. To any of you, let me know. Should we go to 15?
Before we go to 15, so I just want to ask you, like, you see how it says the second condition, 1/2 pi, and then pi.
Right, so this condition is in T, the angle is in the second quadrant.
Okay, okay, I think I get it.
Okay. All right, any other questions?
No.
Okay, let's do 15. 15 said, okay, solve for this equation. Let's see. Also, we want to use a table maybe. Maybe you need to use a table. So we have 4 sine 2t equals -2 radical 3. And for t, t is in these 4 quadrants. So we know already the 2 values of t, right, will give us this value. Well, let's divide it by 4 first, right? So have 4 sine 2t. Let's divide it by 4. Then after we divide it by 4, we get a sine of 2t equals to negative square root of 3 divided by 2, right? I divided by 4 on both
Why
sides.
did you flip?
I'm sorry?
Why did you flip the 2 square root of 3?
Well, I did not flip. I just divided by 4 on both sides. I divided by 4 on this side. I divided by 4 on both sides. Oops. You see 4 divided by 4 is 1. This 2 divided by 4, I get a half, right? I get negative root 3 over 2.
Okay.
Okay, so I get sine of 2t equals a negative square root of 3 over 2. Well, sine be negative. Sine be negative in which 2 quadrants?
The fourth and the third.
Right. So the third and the fourth, right? So let's see. So negative square root 3, okay, let's forget. So we know the 2 angles will be here, one will be here, another one will be here. And the square root 3 over 2, what's the reference angle? So I have a sine equals the square root 3 over 2. Sine value here equals to square root 3 over 2, which is represents 60 degree or pi over 3, right? Let's see 60 degree. So that means, so in this quadrant, I would have the triangle go this way, but my reference angle here, which is 60. Make sense? Let me write here. Let me write 60. So 60 degree here. And the fourth quadrant, I will have my triangle here. Right? And also my reference angle is 60 degrees. I have two quadrants. So by this equation, I got two pictures. I got a triangle in third quadrant. I get a triangle in the fourth quadrant. Because the reference angle is 60 degree here, reference angle is 60 degree here, gives me negative square root 3 over 2. Sine of this angle, what's this angle? Now let me change my color. Let me change to be green color. Oh, why it's not green? Does not allow me to change my color. Okay, anyway. So here, look at this coterminal line, right? This is coterminal line. So the angle for this, for the third quadrant, which is this one, we measure from the starting point up to this coterminal line, which is this angle. Do you see that angle is, that means 2t. Oh, that's for this color change. That means 2t equals to, do you see this is 180 plus 60? 180 plus 60, which is 240. Like this color. So 2t, 2t equals to 240 degrees. Do I make sense here?
I guess.
Okay, so by this value, by this negative value, negative sign be negative, I know my triangles are in third quadrant and fourth quadrant. And which reference angle give me negative, give me square root 3 over 2, which is 60. So I know my reference angle is 60 degree, 60 degree. But that's the only reference angle. So how do I find the true angle? I need to measure from the starting point, right? Starting point from the positive side of x-axis. So going from this up to this coterminal line, I see that's pi plus 60 degree, or 180 plus 60 degree, which is 240 degree. What about this angle? This angle, I start from the beginning, I run up to this coterminal line. I see that's a 360 minus 60, which is a 300 degree. So we have 2t equals to 300 degree. Do I make sense?
Not really.
Okay. Okay, so you're fine from the first step to sine 2t equals to negative square root 3 over 2, right?
Yeah.
Okay, and also you're fine with the sine value being negative, means the triangle in the third quadrant and fourth quadrant, right?
Yeah.
Okay, so now the third point is the value square root 3 over 2 give us a reference angle 60 degree. That makes sense, right?
Yeah.
Okay, so the reference angle is a 60 degree. What's the true angle? The reference angle is 60 degree. What's the true angle? Let me erase all this. Let's figure out in the third quadrant first. The third quadrant, we look at this picture, right? This triangle in the third quadrant. The reference angle is here. The terminal line is super important. Oops, I don't need this square. I want to change my color. You see, this is my terminal line, this one. So
Yeah.
this, right. Okay. So that means my true angle starting from, where's the starting point? How do we measure angle? We start from the positive side of x-axis, right? We
Yeah.
start from this point. We run, this is 90. We run, this is 180. We run this angle. Then we finish at this terminal line. Do you see this angle? Do you see my curve?
Yeah, I see it.
What's this angle? What's this angle measure?
It was 240.
240, right? Okay, similarly for this one, if I keep running, it doesn't keep running. Okay, let's just leave this one here. So we'll measure this one up to this coterminal line. Oops. So basically similar idea, right? So what's the angle measure?
You said earlier it was 300.
360 minus this 60, right?
Yeah.
That's it. So from there, we get 2t. So the angle measure equals 240 degree. Well, another solution is 2t equals to 300 degree because the angle is 2t. Now we want to solve for t. So we just divide by 2 on both sides. So we divide by t. So 240 divided by 2, get 120 degree. And then another angle measures 300 degree divided by 2, 150 degree.
So for sine, you have 2 degrees.
Now the angle measure degrees, angle. So this d means degree, means a little circle, means this little circle on top of the number, just like this.
Okay, but like I'm saying that you have 2 solutions for sine.
Yes, because you know, we always get 2 things, right? 2 being positive, 2 being negative in the 4 quadrants. In 2 quadrants, sine value being positive. In another 2 quadrants, sine value being negative.
Okay.
All right. Okay, great review. Do you have any other question?
Not at the moment. I just wish we could have practiced more of these type of problems
Yeah,
before.
no, I guess I ask it differently, right? It's, the homework questions, I see. No question. Let me see. Do we have a graphing? Okay, let me see some comments in the chat. Sarah is saying if we fail the exam, will it affect our grades? Of course. Lola is saying, I think you should please check the questions on the review sheet again. It's not looking like what I was expecting based on the homework. Okay, you know what? Probably I'll change the questions. It looks like 2 different, right?
Yeah.
Okay, I'll do that. I'll.
Like, can you make sure that you give us, if you, since you said that you will change it, like, can you make it similar type of topic and question based on the homework you assigned?
Yeah, yeah. I'll look through the questions. Maybe I just choose the questions from the homework then.
Okay, thank you.
You're welcome.
Because it's a little unfair that this is like the first, like I know it's the same topic, but like most of the questions that you explained, like I think I understand, but I didn't practice, and then getting a test on that is a little unfair.
Right, right. So I wasn't pay attention to how the homework was asked. Yeah, yeah. I'll do that. I'll just give a new review sheet.
Okay, thank you.
You're welcome.
So then have a nice day.
Oh, you too. Thank you.
Bye.